Okay, so today we're going to cover section 2, and section 2 covers the converse of the Pythagorean theorem. If you recall back from semester 1, when we did the logic chapter, we learned about a converse. And remember, the converse just switched the order. We're going to switch the order of the if and the then. So yesterday, they started out by telling us if a triangle is a right triangle, then a squared plus b squared equals c squared. Today, we're going to switch it. They're going to say, if a squared plus b squared equals c squared, then the triangle is a right triangle. So this is the converse of the Pythagorean theorem. So in words, if the square of the longest side of a triangle is equal to the sum of the squares of the other two sides, then the triangle is a right triangle. So again, it's been switched. The if and the then switched. The next slide has more triples. So I showed you that screenshot from the textbook, but if you look at the last three here, these are actually, again, that 3, 4, 5 just scaled up again. So here, this is just the 3, 4, 5 multiplied by 3, the 3, 4, 5 multiplied by 4, and the 3, 4, 5 multiplied by 5. So again, they like to take different variations of this 3, 4, 5. But again, you can always just do Pythagorean theorem to find a missing side. But again, it always is helpful if you recognize some of these common triples. Yes?
What's the combination for the second one?
The second one is actually a scaled up 5, 12, 13. That's the original one. And then they times it by 2. So that was probably one that I gave you yesterday. All right. Is what first theorem, the second theorem we're going to see. This is actually, should say 7.3. But again, we don't care about the number. Okay. All we're worried about, the theorem says. So this is stating that if the square of the longest side, so the C, of the triangle is less than the sum of the squares of the other two sides, then the triangle is an acute triangle. So what we're going to do is they're going to give you three numbers, and you're going to square the biggest number, and then square the other two and add them. If that biggest side, after you square it, is smaller than a squared plus b squared, then your triangle is an acute triangle. Remember, the other theorem we just learned was if it's equal to, then it's right. One. Now instead of being less than, now it'll be greater than. And if c squared is greater than a squared plus b squared, then it's obtuse. So this one is theorem 7.4. Again, we don't care about the number. We just care about what the theorem states. All right. Before Christmas break, we learned about that triangle inequality theorem. And recall that when you have two sides, or they're giving you three numbers, and they ask you, will these three numbers form a triangle? Remember, we took the smaller two numbers, we added them, and we subtracted them. Do this darker. So if I add them and subtract them, that third number has to be in between these two numbers. So is 36 in between 15 and 35? No. So what you would say is this is not a triangle. So what you're going to need to do when you take the quiz is first check to see if the side lengths will even form a triangle. If they don't, you just put not a triangle. If they do, and this is what we're going to do on the next slide, is we're going to test them out. Let's try it. So if I do that check first on these, what is 20 plus 21? And what is 21 minus 20? Okay, is 29 in between 1 and 41? Yes. So So these three numbers will form a triangle. Now I'm going to apply the theorems I just learned. I'm going to take the biggest number, that's my C. I'm going to square it. And then I need to figure out, is this number greater than, less than, or equal to 20 squared plus 21 squared? So 29 squared is actually 841. 20 squared is 400. And 21 squared is 441. I'm going to add the a squared plus b squared. I get 841. What is the relationship between 841 and 841? Equal to. So when the two are equal, this forms a right triangle. So that's what it means to classify or describe what type of triangle it is. Now, fun fact, one way that I know what 21 times 21 is, everybody know what 12 times 12 is? Right? You learned this in 3rd grade. It's 144, right? What if I reverse the order of 12 and make it 21 times 21? I just take the answer and I reverse it also. So that's how I know what 21 times 21 is. Fun fact for you. All right, let's do the next one. Again, you should double check that this will form a triangle. So you add 20 and 21 and subtract 20 and 21. Again, I get the same answers, 1 and 41. 30 is in between there. So they do form a triangle. So now let's see what type of triangle it does form. So I'm going to do 30 squared, the biggest number, and then I'm going to do 20 squared and 21 squared. I just did this, so I already know what the sum is. This is 841, and then 30 times 30 is 900. So is 900 greater than, less than, or equal to 841? Greater than. So when c squared is greater than, what kind of triangle do I have? Obtuse. Let's try the next one. Again, double check that they do form a triangle. So 5 plus 6 is 11. And then 6 minus 5 is 1. 8 is in between. So this does form a triangle. So take the biggest one, square it, and then take the two smaller ones, 5 squared plus 6 squared. I'm going to square 8, square 5, square 6. I'm going to add them, and I get 61. 64, is it greater than, less than, or equal to 61? Greater than. So again, same type of triangle, it's obtuse. Okay, next one. Again, you're always squaring the biggest one. Now, for this slide, they're actually in order, but they may be mixed up. So 8 is the biggest side here. One way that I could double check it when it's a radical is I could approximate it. So the square root of 3, if you think about it, it's less than the perfect square 4. So it's got to be less than 2. So if I were to do 4 times 1 point something, that would still be less than 8. So let's go ahead and just do the 8 squared. I don't know what's going to happen here yet. And then 4 squared. And then 4 square root of 3 squared. So 8 squared is 64. 4 squared is 16. And now remember to square something that's got a radical in it. I'm going to write this 2 times. I'm going to do outside with outside. So 4 times 4 is 16. And then square root of 3 times square root of 3 gives me 3, because it really turns into the square root of 9, and the square root of 9 is 3. But shortcut, don't bother multiplying the numbers, just make the radical disappear. So then 16 times 3 is 48. So now I'm going to add 16 and 48, and I get 64. So I can see that it's equal to. So this would be a right triangle. I have one more example. Again, I can see that the square root of 10 is the biggest number, because if you think about the next perfect square below that, it's the square root of 9, which is 3. So I already know that the square root of 10 is the biggest side. So the square root of 10 squared, I don't know the symbol yet, and then I'm doing 1 squared plus 3 squared. Remember, when you square a radical, it makes the radical disappear. So this just becomes 10. 1 squared is 1, 3 squared is 9, and then 1 plus 9 is 10. So the symbol that goes in between is the equal sign. So this triangle is also a right triangle. The next slide just has a summary of the 3 different scenarios. So for the first one, if c squared equals a squared plus b squared, then we can see that the triangle is a right triangle. If c squared is less than a squared plus b squared, then the triangle is acute. If c squared is greater than a squared plus b squared, then the triangle is obtuse. So make sure you understand what needs to be the bigger number here. In the past, students think of it backwards. So when c squared is the bigger number, it's obtuse. When c squared's the smaller number, it's acute. When c squared equals a squared plus b squared, it's a right triangle. So that is section 2, and you do have a homework assignment for lesson 2. Any questions?